Hello everyone, and welcome to part 1 of our Getting Started tutorials for structural simulations using Ansys Discovery. Let's get started. If this is your first time using Discovery, please be sure to review all the slides on the welcome screen as there is a lot of great information that will help you get acclimated with using the tool. Once you've navigated to the end, you can simply select Open Homepage or click the X in the top right corner. From here, we need to import our geometry file. As you can see on this welcome screen, we have access to our recent files, our samples, as well as access to our learning content here as well. But to import our own CAD file, simply navigate up to Browse, select the drop-down arrow, and select Open Geometry File. From here, navigate to the appropriate file location, select the geometry file, and select Open. Now that our geometry is loaded, we can begin to set up our static structural simulation. One thing you may notice is that by default, we open our geometries in our Explore mode. The Explore mode utilizes our live GPU solver technology, but everything I'm going to be showing you here today can be accomplished also in our Refine mode, which utilizes our Ansys Mechanical High Fidelity Solver. To access the Mechanical Solver, or simply in the Refine mode, you can click this arrow to the right to go to Refine. Or if you wish to navigate back to Explore to use our live GPU solver technology, you can simply click the left arrow. Now that we're back in the Explore mode, let's go ahead and begin our setup process. The first thing we need to do is make sure we scope the relevant bodies to the physics simulation. So let's go ahead and review our geometry tree, which is going to be in the upper left corner of our screen. And if we click this arrow here, it exposes all of the components within our assembly. As you can see on the left side of our screen here, we have two different icons. The left column is going to be relating to the relevant physics contribution to the simulation. In this case, we can see all green crosshairs indicating that they are all active in our physics simulation. And the right column controls the visibility. So to change these, you can simply left click on them. For this application, we want to focus our simulation to the spindle, upright, A-arm, and a collection of the hardware. So let's go ahead and suppress the struts and chassis. As you can see, they turn to a red circle with a line through it. And let's simply hide those objects as well. Now for this application, we don't need these remaining pieces of hardware that are at the rear connection points to these A-arms. So we need to go ahead and suppress these objects as well. So to do so, I can simply do it with a right click in space after we select the geometry. So let's go ahead and box select around these bolts. You can right click and say exclude from simulation. Now, a great way to keep track of your progress as you go through your setup process here for scoping the bodies is to right click and say hide all suppressed. This helps you hide the bodies as you remove them from physics so that you're only seeing the objects that are going to be simulated on. So let's go ahead and suppress the remaining objects here. So when selecting them for suppression or activation, you can simply select one face on the body. And as you can see, I'm selecting multiple faces here at one time, and I'm doing so by holding Control while I left click. So we just have one more remaining object here, which is a face on this nut. And I can right click, I can say exclude from simulation, and then I can right click again and say hide all suppressed. So as you can see here, if I just left click in space, that we have all of those remaining bolts removed from our application. So this is a correct scoping for this physics simulation. This could also be accomplished by using our quick scope tool, which is available up here on our simulation tab in the ribbon. This is covered in a few other tutorials, as well as a quick tip if you would like to learn more about the quick scoping tool. So now that we have our physics body scoped, let's begin to set up our physics boundary conditions. In Discovery, you can do so in two different ways. You can go ahead and select your geometry first and then select an applicable condition, or you can select your physics boundary condition and then select a geometry. So for this application, I want to go ahead and set up my supports first. I like to set up supports first, but that's just a personal preference. Supports are there to reduce the degrees of freedom and to help constrain your model. So in this application, we know we have connection points at the rears of the A-arm, and we know that the bolt will allow rotation about its mounted axis or that center line, but it won't allow translation in the radial or axial direction. So we need to find a support that fits those constraints. So first, I'd like to select a geometry. So let's go ahead and select the upper two surfaces here. And as you can see, I'm having a little bit of trouble selecting this face. And so if you're ever in this situation, you want to select an object that is behind your cursor, you can use a technique called query select, where you can hold control and then scroll on your mouse wheel. And as you can see, I'm able to scroll through all of my selections where my mouse is located. So in this situation, I want to select this inner diameter. So I'm going to select that one. And I'm going to query select again to select this other face. So let's go ahead and set up and choose a boundary condition. And we could do so in two ways as well. You can select it from our simulation tab up here in the ribbon where you can see you have access to all of our physics controls. Or you can go ahead and click the hex, which exposes our halo, where you can access our physics boundary conditions here as well. So in this case, let's go ahead and access our supports. So let's click the support object. And now once we've selected support, it puts us in our support heads up display where we can confirm or change this condition. So in this case, you can see we have a fixed support, which does not allow any rotation or translation for those selected faces. But in this case, we want to find a support that allows rotation about its axis, but no translation in the axial or radial direction. So by selecting this dropdown, you can see I have a variety of different types of supports here. All of these are covered in our in-depth tutorial for structural simulations, so please feel free to try that out. But in this case, I'm simply just going to go ahead and choose hinged. At this point, I can click enter on my keyboard or click this green mark here with the left click of my mouse, which I'm going to do. So at this point, a few things are going to happen in the background. So it's going to begin to set up our static structural simulation, which is indicated down here at the bottom in this large hex, which is this. This is our simulation information display, or SID for short. So it tells you the types of physics that you are solving as well as the state. And hovering over it also shows you the relevant physics bodies or the bodies that you scoped for your physics simulation. So this is a good way to quickly check to make sure you're simulating on your correct bodies. Additionally, over here in the tree, we have our new physics conditions. As you can see, gravity is included in the tree, but is currently suppressed and excluded from the simulation. We have all of our structural conditions, and we have our connections. We'll be covering connections in part 2 of this Getting Started tutorial. So we set up our first Hinge support. Let's go ahead and set up the other ones, and we're going to do it on the bottom connection points here. So let's simply select this inner diameter here and this one as well. And it's important to note when you're using a hinge type support that the objects must be coaxial or share an axis. So let's hit the check mark again to positively confirm our secondary support location. And we need to apply one more support because we want to represent the worst possible loading case here for this entire assembly. So if we quickly show all of our objects here, the worst case scenario for this lower A arm is when the struts and these springs are at their fully compressed position, meaning that effectively they'll almost act like a rigid connection point. So in this situation, I want to go ahead and represent those areas where they connect to the struts as a hinge type support, just to represent the worst possible loading condition. Imagine you're going down the road and you hit a pothole and your suspension bottoms out. This is the condition we're trying to replicate here. So let's simply right click and say hide all suppressed again. As you can see, we're still in our heads up display here for our hinge type support. And let's go ahead and begin to select the remaining 4 locations down here on the bottom. And the one thing you'll notice here is that if I hover over this planar face here, it's not selecting it. It's actually grabbing the rounds in the background. So when you select a physics boundary condition first, if there is a relevant geometry requirement, in this case for a hinge support, we need some type of cylindrical or rounded face, it's going to put a geometric filter on your selection. So in this case, this makes it a little bit easier if you would like to select your geometry or select your condition first, but it's up to you as the end user as to what you find more efficient. So in this case, let's go ahead and select these 4 faces. So I can click once to select one, and I'm holding control to select more faces. So as you can see, it's a plus sign indicating that I'm adding. And if I wanted to remove a face, so you can see I'm hovering over an existing selection and it turns to a negative sign on my cursor. So I have these 4 faces selected, so we are good to go at this point. So I'm simply going to click the check mark here on our screen, which allows us to confirm that final condition. So now that our bodies are officially fully constrained here, let's go ahead and apply our load to this application. As you can see down here next to our simulation information display, we have a message showing. And this is simply a notification, and this is just an informational message to the user that they need to apply some type of loading condition to this application. Technically, a fully supported system like this is a valid simulation, but it doesn't provide any useful results as there would be no deformation, no stress, or any load within this part. So let's go ahead and apply a force to the front end of this assembly to represent some type of loading condition. So let's simply select this front face here. I want to select this second face and this tertiary face right there. So from here, let's go ahead and choose a force condition. In this case, I'll show you how to grab it from our simulation ribbon. So let's go ahead and choose the drop down and choose force. From here, we can begin to apply our condition. And in this case, we want to enter a load of 1,000 pounds force. And as you may notice here in Discovery, our default units for our simulations are locked in as metric. But we do support unit agnostic import, meaning that if I want to enter a value in a different unit system, Discovery will simply do the conversion for you. So as you can see, I can type 1,000 and I can begin to type LBF if I would like, or I can choose from this drop down here and choose pounds force as my units. So as you can see, it applies that condition, it gets added into our tree. And as you can see, the direction doesn't seem quite right. And it's based on a normal selection. So the arrow is going to point normal to our geometric selection. And in this case, we want to go ahead and change it. And we can do it in two different ways. The first way would be to simply update our X, Y, and Z vector components for this force. And to access them, you can simply click this double arrow here to expose your X, Y, and Z vectors. So as you can see, all of this force is going down in the negative Y direction. So in this case, if you know your X, Y, and Z values, feel free to enter them. But there's also a secondary way where you can use other pieces of geometry as reference. So in this case, let's choose this object here, which sets the direction of this arrow based on my geometric selection. So let's go ahead and utilize this edge right here to go ahead and orient our force in that direction. So as you can see, it's now oriented in the Y and negative Z directions. So let's just go ahead and use this as the correct orientation for our force. One important thing to note is that we do support remote forces here in Discovery, meaning the force would originate from some other location. And to activate this, you can simply click this Use Remote Point Object to expose the X, Y, and Z origination point for this force. But for this application, let's just go ahead and leave it at its original location. So now that we've applied our physics boundary condition and we've applied our supports here, so let's go ahead and do one final step here for part one of our Getting Started tutorial. And that's going to be related to the material definitions of the objects here in our assembly. As you can see here on the left side of our screen in our physics tree, we have a structural steel definition, and it's our only material definition. So if you would like to change every object in this assembly to a singular material definition, or you'd like to change them to something different, you can simply double click this material definition over here. And what this is going to do is highlight all of the objects that are tied to this material definition, and it allows you to change it using this drop down here. Additionally, you can visualize all of the relevant physics properties. As you can see, they're all related to structural. If you would like to see thermal properties or some other properties, you can click the arrows again to go ahead and visualize ones that are not being used in the simulation. Additionally, you can go ahead and edit these if you would like as well. But for this application, I want to keep all of the objects in my assembly here as a structural steel, except for the upper A-arm, the upright, as well as this lower A-arm. And I want to change them over to an aluminum. So as you can see, as I'm selecting these bodies by triple clicking, I'm able to visualize their material definition. And so this is one way in which you can change the material of an object simply just by selecting it. So I triple click to select the solid, but you also notice here that I need to triple click to expose the entire object. If a single click here, if you notice, it doesn't pull up the material definition because the material definition is tied to a body, not just a face selection. So in this application, let's go ahead and choose an aluminum definition. Let's go ahead with the 6061 just for this upper AR. So by triple clicking to select the solid, I'm able to change the material. From here, if I wanted to see material properties, I can click this double arrow here and I can click properties. These are all just tied to the volume and mass in the background. But I can also go ahead and begin to change it here. So all I need to do is begin to type aluminum. So I can go ALUM, and you can see that my list is now filtered down to all materials that start with ALUM. And in this situation, you'll notice there's a couple different icons here. The one that I'm highlighting over now with the discovery symbol and the material icon, these are ones that we provide natively as well. But you can also access the ones with diamonds with a Granta material license. But for this application, let's stick with our native materials. So in this application, let's go ahead and scroll down until we can find a 6061. In this case, let's choose this default material here. As you can see, the aluminum alloy assignment is now selected in our tree for us. Now let's go ahead and change these other two bodies here. In this case, the upright as well as the lower A-arm to aluminum as well. In this situation, let's not use this quick access menu here. Let's use our materials objects that are available in our hex. As you can see, we can access materials here, or we can choose the object up here on our ribbon. So it's up to you, whatever you find more efficient. If you use the halo here, there's a quick selection that allows you to go ahead and select some of your favorite materials or some of your most recently used. And also, if you click this other one, it allows you to go ahead and expose your entire material library. One important thing to note is that if you cannot find a material that you like within this library, you can simply choose user-defined solid to create your own material. So in this one, let's go ahead and begin to type aluminum again. In this case, we started with our hex and our halo using it this way. And let's scroll down and choose that same aluminum 6061 material assignment here as well. So this concludes part one of our Getting Started tutorial for structural simulations, and we hope that you found it helpful. And be sure to tune in for part two. Thank you and take care.